Hey everyone, welcome and thanks for tuning in for this update from the world of k0s, or like we call it, the frictionless Kubernetes. I'm Jussi Numelin. I'm part of the team behind k0s and Cosmotron, and today I'll walk you through some of the latest updates from the project, recent releases, what we're doing next, and especially how you can be part of what we're building, whether you're running on edge clusters, on a potato, or orchestrating fleets of clusters in the cloud. I think we got some fun stuff to share, including some CNCF related news and of course the latest updates and what we're headed next. So let's dive into it. First of all, for the folks who are not that familiar with k0s and Cosmotron, let's have a quick-ish recap on what they are and what's the whole kind of idea behind those projects. K0s, in a nutshell, it's Kubernetes without all the yak shaving. k0s really started with an idea that what can we do to make Kubernetes as simple as humanly possible, and quite quickly that revolved into an idea where let's build everything into a single binary which has no dependencies whatsoever apart from the Linux kernel itself. Of course, we can't run containers and any of that fun stuff without the support of Linux kernel. What it really means is that k0s is really, like mentioned, a single binary, everything statically compiled. So what you can actually do is you can get the same binary, drop it in Alpine, drop it in Ubuntu, Red Hat, whatever is your favorite distro, and it just works. It comes with all the bells and whistles to run Kubernetes. So actually it embeds all the kube API servers, schedulers, kubelet, all the components, so you don't have to worry about dependencies or anything. What's unique in k0s is also basically from day one we built this true control plane worker plane separation. What it in practice means is that when you run the controller node with k0s, you don't actually get kubelet or containerd running at all, unless you specifically want it. So the control plane is kind of actually sort of separated from the cluster in a way, or not part of the cluster in a way, so we don't have to stretch the CNI, for example, between the controller nodes and worker nodes. And that gives you a lot of flexibility on deployment architectures. You could run the control plane in, say, on a cloud provider VMs, and then the worker nodes in your basement behind layers of NAT and firewalls and whatnot. Zero friction has always been our kind of driving mantra in a way. So we do everything we can to take out friction of running Kubernetes. So you don't have to worry about fine-tuning the components. You don't have to figure out what you actually need to do to Kubernetes for this true controller worker separation, for example. We do it out of the box. And try to keep the user experience as easy and frictionless as humanly possible. It is still Kubernetes, yes, which means that there is always some level of complexity involved. And also, k0s comes with all the batteries included, but they are all also swappable, meaning that k0s comes with containerd, for example, as a default, but you can use basically any other CRI compliant container runtime, like CRIO, Kata containers, Docker Enterprise from Mirantis, or you name it. And just an example, as a zero friction, we have this curl way of setting up k0s. Just curl the get script and pipe it to shell, and within a minute or two, you actually have Kubernetes at your hands. Yeah, I mean, of course, none of us should really pipe scripts from internet to shell. But just as an example, how super easy it is. At least download the script first and see what it does, and then maybe execute it. But at least it's super easy to get started with. And then Cosmotron. Cosmotron actually came out of the controller worker separation in a way. And because we have this capability and have had that capability from day one with k0s, we basically started to think that, do we actually need always virtual machines or machines in general to run the controllers? Because there's no containers running, there's nothing like fancy stuff running there in a way. We basically, on a controller, we run plain Linux processes for all the needed components like API server, schedulers, whatnot. And that actually quite quickly revolved into an idea that hey, could we run that stuff in Kubernetes? I mean, they're just ordinary Linux processes. And that's what Cosmotron essentially is. It's a control plane provider, and it really runs the controllers in pods, which means that now you can have your management cluster, or what I usually actually call a mothership cluster, that then hosts control planes for multiple clusters. That was the basic idea of Cosmotron from when we started a couple of years ago. Quite quickly from the community, there started to come kind of requests that okay, that's cool and all, but could Cosmotron also be a full cluster API provider? Because we already have cluster API that defines this declarative way to create and manage clusters using an existing management cluster. And those models kind of fit together very nicely, because they are essentially based on the same kind of pattern. And now Cosmotron is a fully compliant cluster API provider for k0s clusters. So you can use cluster API with all the gazillion different objects that it has, unfortunately. And then you can actually declaratively define your k0s clusters utilizing the CAPI contracts and manage everything in a declarative way. One of the things that Cosmotron has is it actually has two different providers for control plane providers for CAPI. One is the kind of hosted control plane way, where we run the control planes in pods within the management cluster. And the other one is the more kind of traditional way of running clusters with virtual machines on say Amazon or Google Cloud or whatever cloud provider you have at your hands. The cool thing with the hosted control plane way of running things in pods is that you actually get kind of fully isolated multi-tenancy model, because each of those clusters are really independent clusters. They don't share any worker nodes, they don't share any resources other than the management cluster CPUs and memories, of course, but from the cluster point of view, they are really fully isolated. And of course, we get fully declarative management for the control planes, and then with CAPI for the whole clusters. So that's super cool. If you have been following k0s at all, at this point you probably already heard the news that k0s and Cosmotron are now accepted as a CNCF sandbox project. The technical oversight committee had a vote on January 16th, I think, or mid-January anyways, and the vote accepting k0s and Cosmotron as CNCF projects was unanimously passed. So that was super cool. But of course, I mean, we're not applying to CNCF sandbox just for the fun of it. So let's see what it means. Of course, community has been in our thoughts and heart for basically from the beginning when we open sourced k0s in 2021, if I remember correctly. Time flies when you're having fun. But with the support of CNCF or kind of backing of CNCF now, what we really get is and by we I mean the community around k0s. What we get is kind of like full transparency in a way, because one of the things that are fully required by CNCF and all the projects is a fully open governance model, and what that leads to eventually, at least, is kind of like community-led development work and community-guided work, in a way that community has a first-class citizen seat when making decisions. We've started to work on the governance documentation, and it's already pretty in a pretty good shape, I'd say. So because as you probably know, an open source project is quite often more than just one repo on GitHub. So what we decided to do is we actually created the separate repo for all the community and governance documentation. So if you go to GitHub, k0s project, and under that there's a separate community repo that has all the governance and other such documentation. And of course, for you as a community, read that through. Whether there's something to improve, let us know in the issues or pull requests. The other topic I wanted to touch is innovation. As we know, open source in general is really a good driver in innovation, and we've seen so many innovations in open source in the cloud native ecosystem. So with the help of community and backed now by CNCF, I think what we want to do is really push the boundaries of how simple we can make Kubernetes, how small we can maybe push it, and just overall enhance the zero friction statement that we've always had. And with the community, we might figure out some totally new use cases where we can use Kubernetes and k0s, and it's all about innovation. The third major thing that we are already actually working on is collaboration. So we've already touched base with some other CNCF projects. I met a lot of people at KubeCon, which was last week, and oh boy, that was fun. But I met so many different other CNCF project maintainers. We discussed some ideas, how to collaborate, how to integrate k0s with other projects. As an example, we're already planning an kind of native how to say it, integration plugin. Let's call it integration. Native integration with Flatcar Linux using systemd system extensions, just as an example. The folks at the k0s project, another CNCF project, they've already integrated support for k0s. So with k0s now you can get kind of operating system images targeting edge-like deployments with k0s in it. So that's super cool. And by innovating together and collaborating with other CNCF projects, we are really aiming to advance the whole ecosystem. And of course, within all of this and in the heart of this is you guys, the community. What's new in k0s from more technical point of view? As you know, we've always had this kind of strong urge to keep up with the upstream as fast as humanly possible. What that currently means is that our maintained release branches 132, 31, 30, and 29 are already released with the latest and greatest Kubernetes versions. I mean, patch versions in this case. Usually the release cadence of k0s follows quite strictly the upstream Kubernetes releases. We're usually for patch releases we're like week, 2 weeks behind, because we have to do the integration testing. We need to make sure that all the other components are up to date in their patch versions and so on. So that takes time and effort and all that, but it's the benefit for the community, of course, because we really do run rigorous testing on those version combinations. For new minor releases, we're a bit more behind, because as you probably can figure out, a new minor release is a bit more work. Kubernetes might have changed some things. There's some new features in Kubernetes that we want to also incorporate in our testing and those kind of things. But as you know, k0s is more than just the upstream Kubernetes in a way also. So there's like unique features in k0s in itself. One of the new features is an embedded load balancer that we've titled with CPLB, a control plane load balancer. The reasoning behind that is actually quite simple. k0s is targeting both the usual environments like cloud providers and those kind of more dynamic environments where you actually have things like load balancers that you can get with the click of a button and so on. But there's a lot of use cases where people are using k0s where they don't have that luxury. And as we know, when you go to highly available setups, you pretty much have to have a load balancer in front of the API servers, and then the component that enables this control plane worker plane separation called connectivity actually kind of requires a load balancer also. So basically we thought that okay, people are running k0s on those kind of environments where they don't have the luxury of click of a button load balancers. Can we do something about it? And from that, we created the control plane load balancer. So how it works is it's a VIP virtual IP based solution, and we didn't reinvent the wheel. No one wants to reinvent the wheel. So it's actually using Keep Alive D for the virtual IPs, and then IPVS or user space backend doing the actual load balancing. So basically when you have like 3 controller nodes, you configure the virtual IP, something that fits into your network, something that doesn't clash with your network. And with that, k0s actually boots up and configures Keep Alive D, configures the backend, and boom. With few lines in YAML, k0s YAML configuration, you actually have a dynamic load balancer implemented for you. So that's super cool. Another notable new feature is the optional flag for kubelet root directory. As you probably know, if you played with k0s, k0s tries to store everything on disk under var lib k0s. All the kubelet stuff, all the containers, containerd states, all the certificates, basically everything under there. What we've unfortunately found out is that in the ecosystem, there's still a lot of, I don't know a lot, but at least some amount of components that don't really allow any configuration where kubelet data is. So there's components that have basically hard-coded var lib kubelet path in some of their code. What that means is that by default they actually don't work with k0s because the kubelet path is different. So the whatever component is like CNI or CSI, we've found a couple of those. They're just looking kubelet in a wrong directory and they don't work. So for those kind of use cases, we added kubelet root directory flag for k0s. So actually now k0s can put kubelet data and all the device registration sockets and things like that in the standard var lib kubelet path, for example, or whatever path you decide to use. So another kind of user experience flag in a way that with that it allows to use those not so configurable add-ons. Other thing in k0s sort of new in a way is support for NF tables mode in kubeproxy. It's been in beta since 1.31, and since 1.31 k0s has allowed you to actually make it work or enable the NF tables mode in kubeproxy. It's gonna go in GA in 1.33, which means that IP tables will still be the default for backwards compatibility reasons, of course. but we're now integrating NF tables to all the all the testing matrices that we do. So we will be testing k0s with kubeproxy and all those CNIs and whatnot components, both in IP tables mode, IPVS mode, and NF tables mode. And if you've been following the IP tables, NF tables saga that's been going on for years, I think I would strongly urge to start to look at the NF tables instead of IP tables. Not only because of performance reasons, which are actually the biggest reason, but also since we've seen some cases of incompatibilities with the IP tables too. There's blog posts and I've had conference talks on that subject, so you can probably find those in YouTube. Another thing kind of new in k0s is declarative way to manage etcd membership. Yeah, that's the correct word. That actually means that when you create a control plane node with etcd, of course you can use kind too, which is super cool, and you actually get an object in Kubernetes API called etcd member for each of the controller nodes. With that, what you actually can do is declaratively say that, okay, node 5, you should now leave the etcd cluster. The main use case for that is actually Cosmotron, because Cosmotron manages the control planes very, very declaratively through cluster API or in a standalone mode. And Cosmotron has to have a way to delete members when it does a rolling upgrade for the machines. All right. That brings us actually to Cosmotron. Like I mentioned before, the biggest kind of change in Cosmotron from the initial idea and initial implementation to run the controller nodes as pods, it really quickly evolved into supporting cluster API. And of course, as for those folks who know cluster API, it's somewhat complex. So it took a bit time to figure out, like, of course, how CAPI works, how the different CAPI controllers work. But quite quickly we were able to implement all the CAPI contracts, and Cosmotron is now set of cluster API compliant controllers. And since that, we've been actually evolving the support for cluster API. Like Cosmotron supports also the machine health checks for both worker nodes and controller nodes. And by nodes now I mean the real virtual machines or machines in general. We've also added support for failure domains. With cluster API, you can basically say that for this provider we have these 3 failure domains available, and then Cosmotron can automatically balance the controller nodes, for example, on the failure domains. So if you have 3 failure domains and you want to have 3 control plane nodes, there's going to be 1 node per zone, right? Or failure domain, which usually maps to a zone in a cloud provider. We're now very, very shortly gonna do a new release where we also add support for validating webhook. We've found out that the cell expressions and typical CRD validations just don't cut it anymore for Cosmotron. So we're adding a validating webhook for some use cases for better user experience, so that you're not allowed to shoot yourself in a foot anymore. And also we've implemented support for topology spread constraints for the hosted control plane use case. So basically it allows you to tell that, okay, how do we want to balance the pods between zones and nodes and whatnot. So basically giving you more controls how to spread things. Looking ahead with k0s, and of course this is definitely something where you as a community you have a say in this. So these are just our ideas from the core maintainer team. Of course, the main thing is that we need to keep up with the upstream ecosystem. By that I mean Kubernetes releases, keeping up with all the components that we have, containerd, runc, different CNI providers that we have support for, and a lot of other components. So there's always a lot of version bump PRs going on, which is like I'd say the kind of like the typical chore work for us and many other open source projects. One area that we are kind of revamping the work is for Windows workers. As you might know, we've sort of had a very experimental support for Windows workers, but since it has been very experimental, there's been very little use for it, and thus it's kind of rotten in a way. So we're kind of now started to work on sort of refactoring or redoing the Windows worker support in a way. And hopefully in near future, k0s can actually support Windows workers. I'm not giving any timelines on that. You know, Windows in general is quite a different beast than Linux that we're more used to working with, so can't really give any timeline commitments. We also are working with better alignment for C groups and init systems. My colleague Tom actually had a talk at the Rejects conference last week about the whole C groups and how C groups work, how kubelet configures C groups, and the whole container stuff, how it impacts C groups. And we want to basically have k0s to sort of play nice with C groups and init systems in that respect. We've also had some ideas how to improve the configuration and configurability of k0s itself. You know, as typical project, we've been kind of doing a lot of adding features, adding configuration knobs here and there, and you know the current configuration format has kind of naturally grown or evolved into the state what it is. It's not bad at all per se, but it just creates a bit of friction in the implementation level currently. And basically we want to, at some point in time, we want to introduce configuration version 2, where we fix the design flaws in a way and make it more usable, more manageable, and especially more maintainable for us maintainers. And of course, like I mentioned already before, there's some discussions going on with the other ecosystem projects like Flatcar, k0s, and some others. And we're either working on those integrations ourselves or helping others, and it's community work. On Cosmodrome side, of course, again, we need to keep up, and in this case, keeping up really means keeping up with the cluster API. Cluster API is of course evolving always, so we need to make sure that Cosmodrome still respects and implements all the needed contracts for different providers like the control plane provider, bootstrap providers, and those kind of things. There's been few requests and discussions on supporting in place upgrades with Cosmodrome. And by in place, what it means in this case is that, for example, the controller nodes running on VMs on Google Cloud, we could actually update those, the k0s version on those nodes without creating new machines and deleting the old ones, because that's the usual kind of rolling update strategy of Cluster API. While we actually can do that with Cosmodrome and k0s, because remember, k0s has this autopilot component that can actually update the cluster within the cluster itself. There's some things in Cluster API that doesn't really work well at all, or work at all in those kind of scenarios. The main hindering thing is the fact that in Cluster API, the machine representing the VM in a cloud provider, for example, the machine holds the version information, and if we do the update via Cluster API and sorry, not via Cluster API, via the k0s autopilot, the machine object and the actual version, they kind of mismatch now. And then Cluster API thinks the version is something, but the version is actually different, and then things start to go sideways. There's some discussions going on, and there has been a lot of discussions going on in Cluster API for the support of in-place update strategies. Unfortunately, the work hasn't progressed that much, but hopefully in near future we can also put effort into that. And I actually had few discussions at KubeCon last week. I met with different people working with and working on Cluster API, and basically they said that they also want to have in place strategy as a first class citizen. So we're now hoping to join forces together and help upstream Cluster API to finally make in place updates a first class citizen. Other thing that has been requested on Cosmodrome is kind of out of cluster hosted control planes. What Cosmodrome currently does it when you create the custom resource to get you a control plane. It basically boots up the control plane pods within the same cluster where the custom resource lives, right? I mean, that's quite obvious. There are some use cases where people would actually want to kind of spread the clusters, the hosted control planes in different clusters. So for example, for some very highly regulated user, you could actually run a dedicated cluster for a dedicated control plane. So we're looking now if if that would be viable to implement, and especially then if we decide to do it, we definitely want to use the SIG multi-cluster work as a base, and especially the inventory part. So the SIG multi-cluster inventory is basically like defining how you can tell what are the other clusters where we could actually run things. So basically you'd create this, I think it was called cluster profile. Yeah, cluster profile custom resource telling that, okay, we have this other cluster available at our hands, and then you have information how to connect to that and those kind of things. The SIG multi-cluster is a very interesting working group in general. So if you are working with multiple clusters, I highly recommend to take a look at their work and where they see things heading towards, and of course, that's also a community effort. So go and participate if that's near your heart. Speaking of community and contributing to community work, I do also have some call to actions. Mainly, we are a community. We want to share the love in a way. So if you already haven't been working and playing around with k0s, I strongly urge you try it out. Try those out. See how it works. Whether you get any ideas, how to enhance things. If you find a bug that you seem that this is super small thing, just create a PR to fix things. Bug reports are always welcome. It's a community effort. And as a community, I'd like us to also tell others what you're building. So write a blog post, contribute to conferences, whatnot. And if you wanna collaborate with the maintainers, we're always happy to collaborate on conference talks or blog posts or whatever way we can share the love. Or if you're running a podcast or something, I'm sure one of the maintainers would be happy to join as a guest. So to stay in touch, everything is of course in GitHub under k0s project organization. We have k0s users and k0s dev channels in Kubernetes Slack. And the difference between those channels is kind of like the users channel is for regular users, and the dev channel is more like maintainers discussions on different things, but it's not that black and white. And for those who's already been playing around with k0s and are more familiar with k0s, I'd really like to invite you to help us to help others on different discussions and questions, especially. We're a small maintainers team, so we can't unfortunately do like a priority 24/7 support on Slack. So I mean, yeah, we maybe could, but then we can't do anything else anymore. So yeah, let's make it a community effort also on Slack. We also have k0s project on Twitter, no, sorry, X platform, and maybe also on, I think we also have an account on LinkedIn or whatnot. So if you work with something cool, some cool use case, have things to share about k0s in general, you can always tag that handle, and then of course the usual hashtags like k0s or k0s project or k0s something. That's it from me. Thank you, and thank you for the existing community folks participating in the project, and we want to make this even stronger now, backed up by being a CNCF sandbox project, and we really want to grow the community, and any open source project is a lot stronger with the support of community. So with that, thanks, and I'll see you around.